Good afternoon, everyone. My name is RIKINESH APPU, matrix number B0922104469, and my team members' name are NAVENDRAN, KALATHARAN, matrix number B0922100361, KISSHOCK, matrix number B0922100131. Today, I'm going to talk about my Lab 1 experiment, design and analysis of car disc brake system from subject code vehicle brake system being vehicle brake system. Let's start off with our introduction. The objective of this lab work is to demonstrate the design and modeling process of critical braking system components, specifically the car rotor and caliper, using CATIA, a powerful computer-aided design system CAD software. These components play an essential role in the performance and safety of modern vehicles by converting kinetic energy into heat energy, thus reducing the speed or bringing the vehicle into a stop. In this lab, the design process involves creating accurate 3D models of the car rotor and caliper, understanding the structural and mechanical properties, and evaluating their interaction in the braking system. The rotor, typically made from cast iron or carbon composites, works by generating friction with the brake pads when the caliper applies force. The caliper, often made from aluminum or high-strength steel, houses the brake pads and exerts the necessary clamping force on the rotor. Using CATIA, students will gain hands-on experience modeling complex automotive components, while also understanding the importance of material selection, design parameters, and the influence of various forces on the system performance. The lab aims to enhance students' understanding of automotive design principles and gain insight into the role of CAD software in developing critical vehicle components. Now let's go further on our data finding analysis. I am deeply sorry for our slight error. Young modulus and material name have switched, but the value is same. First of all, let's start with our material name. Material name is iron, and further on in Poisson ratio, density, thermal expansion, and resonant yield strength, and on the right side we have our units. Now let's look at our construction or how we made the Katia model of our disc brake or disc washer and of the caliper. The model may not be perfect, but it's understandable, and roughly from viewing point we can understand that it's a brake caliper or brake rotor. This is our translation displacement. And this is our one stress diagram, and this is our recording process to find out the value for one is stress and translational displacement. Okay, let's proceed with our. This is our displacement model. This is our one Mrs. Stress screenshot model, and this is our translational displacement model. Okay, these are the results gained from the data or drawing before. Maximum one Mrs. Stress, minimum one Mrs. Stress, and translation displacement. On the left hand side, we can see the value. On the right hand side, we can use the unit used to measure the certain parameters. Okay, next let's look at how to calculate factor of safety. To calculate factor of safety we must divide yield strength by ultimate strength. Um, Factor of safety we must divide 310 by 344,000, like based on the value above. Maximum stress is 344,000. So factor safety, the answer is 9.012 times 10 plus negative 4. Next, our discussion. Our Katia drawing allows us to observe the one meter stress, which ranges from 344,000 to the maximum to 582 at least. We can affirm and understand that our disk motor is safe to use because the safety factor is within the acceptable range, which is 9.012 times 10 plus negative 4, based on the data provided by the analysis. Lastly, let's look at our conclusion. What we learned from our lab is, in conclusion, we have learned how to demonstrate the theory, application, and maintenance of the most recent and modern car brake systems. Additionally, we also learned to analyze a disc brake system and determine whether a disc brake system is usable or not, and to understand the maximum and minimum one misses stress. And we can also understand the by understanding the values of the maximum one misses stress, we can also determine if it's safe to use on our car or not. Thank you. Thank you for your time, sir. My name is RIKINESH. Thank you for your time.